Hello and welcome to the channel. Today I'm here with a beautiful chapter to complete in this one short session of your grade 10 mathematics that we are doing for CBSE board, right? You know me, I am Ankit sir. I take maths on our channel Diksha Vedantu for class 10th, okay? And today's chapter is very interesting. It's actually real numbers. I understand some of you might be thinking, sir, this is actually the first chapter in the NCERT. Why doing over here? So what we have done, now once we started the algebra, I wanted to finish this completely. So your algebra is over. Yes, you are supposed to ask me the doubts. If you have any concern, you ask me what else you want from me. But from my side, algebra is completed. Now we are moving to the number system. So where is the number system? Actually, the real numbers chapter comes in the unit of number system. Sir, what other chapters are there? Luckily for us, there is no other chapter. The number system has only one chapter, which is real numbers, and it's worth 6 marks. Right? It's worth 6 marks. So we'll see the weightage, we'll see everything. What is the topics inside the chapter? All will be there. First of all, let me ask you, how are you all? Doing good, right? Let's start. So starting with chapter plan. What is there inside the chapter? We will talk about fundamental theorem of arithmetic, okay, and prime factorization. Okay, I know all of you might know this, but still stick with me. Learn one more time with me as a revision only, but please learn with me. Very important, prime factorization. Then we'll move on to the world of HCF and LCM, and also word problems on them. So this will also be covered. Next up comes your irrational numbers, problems and proof statements. Remember, proving root 2 is irrational, proving the combinations is irrational. We'll solve those questions as well. Now, before I start the session and tell you the weightage of the chapter, I want to tell you about us. Who are we? Who am I? I am the part of a very, very big Diksha Vedantu family, which is known for producing top results, top ranks, toppers, achievers in CBSE board for last 27 years. Okay. For grade 10, we have produced ultimate results. Okay, we can't show all the numbers over here, but if you try to get to know about us, you'll be very much amazed what we've been doing in this field of grade 10 for CBSE students. Okay, now what is this gonna make sense for all of you? If you start the preparation right now, I'm telling you, there's been some changes in the pattern. The board is being conducted in a different way right now. So if you are looking, being a little bit puzzled right now, there are a lot of changes coming your way. So to resolve all of this, we are here. We are here to help you. Just subscribe the channel right now. Subscribe right now. If you're watching this video for the first time, if you're learning from me for the first time, subscribe this video right now. Subscribe the channel Diksha Vedantu for class 10th right now and see your score, see your understanding of the subjects, shoot high. Okay, basically every time you start learning from us, you'll feel the difference that you knew the subject now in a better way. Okay, so and one more unique thing, the most unique thing about this platform is going to be, we'll teach all the subjects, not only maths, not only chemistry. You can see we have been given the classes of social studies. So on our platform for Diksha Vedantu for class 10, we'll teach all the subjects. We'll let you know all the updates coming your way from boards. Okay, anything that you need will be given on this platform, and all will be done in the medium of English. So make sure that you subscribe to the channel right now and keep the notification bell on so that you don't miss out on any of these things. Okay, chali. Now weightage part. As I said, number system 6 marks. Unit name is number system. 6 marks is coming. Now from this is again nothing. There's nothing given like this. I have done my own analysis. I went through your PYQs and understood that in the category of HCF LCM, they can ask you either MCQ, they can ask you 2 marker, sometimes 3 markers, the word problems, and the 4 marker case studies. This is not a structure given in any of the book. I made my own analysis. I opened your PYQs. I opened a question bank and saw for the HCF LCM, MCQs are coming, 2 markers are coming, 3 markers are coming, 4 markers are coming. My own analysis. I put some effort from my side and getting this result. Okay. Irrational numbers, MCQs can come. 5 marker question, the proving question can come. It actually repeats every once or twice in 2-3 years. 3 marker also is there in the case of irrational numbers. So this is your category where the mark can be asked from, the question can be asked on these marks of questions, and of course 6 marks is the total weightage of the chapter, which is very, very important, knowing the, of course, difficulty level, which is very easy, right? Very easy chapter. First thing first, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Now I know that many of you complete the chapter and you don't know this definition. Because what happens, no, you don't need it actually. You are actually applying this concept without realizing it. Remember, you write the number 88 as 2 into 3 into 11. So this is prime factorization, correct? So this, I know that many of you, and even teachers in some schools skip this because this definition is already, built in your head. You've been solving questions on this for a long time, so you don't give that much of importance to this definition. But what happens, no? A question came in MCQs based upon this statement. Then everybody got okay, conscious, okay, fine. Even this is very important. This has been there in the textbook for a long time, but we've been skipping this. Not important, we all know. Teachers tells us in 1 minute, we forget about it. Remember, this happens with you in your class. Teacher is telling something, but you are talking with your friends. Okay, maybe you heard it, but you didn't pay attention. Hearing and paying attention is different things, right? So if you didn't pay attention, you'll forget about the statement, and this was one concept like that, okay? But now this is very important because yes, MCQ can be framed on this and you will be stuck if you have not known that. I'll show you. I've taken a couple of questions based upon this concept directly. So what this theorem is, it talks about every composite number. Each and every composite number can be expressed in the form of products of primes. Please check. Every composite number can be written or factorized as a product of primes. That's it. I did that. 88 is a composite number or not? It's a composite number. All of you agree with me? 88 is a composite number, sir. Okay. 8 into 11. 2 power 3 is what? 8. 8 is also composite. So I written this as 2 power 3. 2 power 3 into 11. So each and every composite number can be written as a product of primes. So we knew this. I'm telling you that. Of course you know that. You use that without knowing the definitions. Okay. So this is the fundamental theorem of arithmetic. I've taken a question on this. 14 into 41 into 5 plus 14 is a composite number. Yeah. Let's prove why. I can take 14 common from these two. I get 14 common. This is going to be 41 into 5 plus 1. 41 into 5 plus 1. Okay, how much is this? I've taken 14 common, right? It will become 2 into 7. 5 into 5. 5 for the 20. Okay, plus 1. What is this? 2 into 7 into 206. Right? You can factorize this also. 206 can be factorized again. So basically, I can write the given number in the form of, this can be also factorized. Okay, we'll have 2 into 103. Check with 7. No. We have 7, no, not 7. What about this? 103 is a prime number. Please check whether it is not 7, 9, not 9 as well. So we have 17. Let's try. 17 9s are. Doesn't make sense. No, not 17 9s are. 13. 13 3s are no. 13 10s are of course not. 13 nothing else works. So nothing. Okay, basically no. So 13 into anything you multiply will not be giving. It's a prime number. So basically I'm getting the result in the terms of product of prime. This given composite number is the given number is composite because of the representation of the given number in the form of products of prime. Prime. All is prime numbers. Got it? So yes, questions like this can come. Now what we were doing actually is called as prime factorization. You take a number like this. Let's say 242. A number is 242. I want you to express this number in terms of their prime factors. Find the factors. So we're going to find all the factors of this number. Okay, you have this method. 2 1s are 2, 2 2s are 4, 2 1s are 2. What is the multiple over here? 11 into 11. So I can write this as 2 times of 11 into 11. Now this is called as prime factorization method of finding any numbers factor. Okay, this becomes very, very important when you deal with the questions in HCF LCM. Okay, for various numbers, writing 64, 2 power 5, basically writing a number in terms of its own factors. That's it. And what type of factors? Only prime factors. In terms of only prime factors is called as the method of prime factorization. Sir, this is what we know, sir. I understand you know this. It's okay. We'll keep moving on. We'll see more and more questions, more and more concepts. Next up, HCF and LCM. Our next world of HCF and LCM. What is HCF? HCF is if I take two number, the number which can divide, the largest number which can divide both the given numbers. If I talk about, let's say, AB, okay, so HCF of AB will be a number which is largest in nature, which can divide both of these. Example, take, let's say C I'm taking in this case, but if I take the example, I'll take 48 and let's say 12, 48 and 12. What is HCF of 48 and 12? I know all of you must have got the answer right now. The time I said the question, you all got the answer, no problem. If I write the prime factors of 48, I'll get some answer. I write the prime factors of 12, I'll get the answer. I can use from there. But in this question, we all know that simply 12 times 1 is 12. 12 times 4 is 48. It means HCF is the 12. Actually, there is another name of HCF. If I tell you that, no, things will be easier for you. Something called as GCD. GCD, what it means? Greatest common divisor. Greatest common divisor, okay? Means a number which is highest in nature, which can divide both the given numbers. Let's take a bigger number. Okay, if I have 720 and 16. 720 and 16. What is the SCF over here? 720 is what? You have to factorize this. 720 will be 2 times of, can I do it directly with 6? Not 6, we'll do with 4 actually. We'll do with 4. So we get here what? 4 ones are 4, 3 is there, 18 fours are, okay. We'll do one more time with 2, I get 90. We get again one more time with 2, we get 45. Okay, what is this? 5 and 9. So we can write the 720 as, check this out, 2 power 1 here, 2 here. So 2 power 4 into 5 into 3 square. 16 into 5 is 180. 80 into 9 is 720. This is the prime factorization of the number 720. Okay, that's the prime factorization. So basically, check here, for 16 what we have? 2 power 4. So isn't this thing is the GCD? So 2 power 4 is nothing but the number 16 is the HCF of the given number 720 and 16. Alright, now actually either this, remember the definition, or whenever you're talking with respect to a question in the factorization form, especially in the prime factorization form, then there comes a concept. You look for all the common factors, with least powers. Okay, if I'm looking for this, please check. For this we had a factor of 2 power 4. I'll show you. Just give me 1 second. 720. What are the factors that we have? We have 2 power 4, we have 3 power 2 and 5 power 1. Okay, but for 16 what is the factor? We have 2 power 4. So what is going to be the HCF value? You will look for a common factor. What is the common factor? 2 over here. So write 2 with the least power. What is the least power in this case? For 2, basically in this case it is 4. Okay, answer will be 16. That's my HCF value. So what is HCF? HCF is the only common factor with the least power. Whereas in the case of LCM will become all the factor with maximum power. In this case we have only common factors. In LCM what will have? We'll have to do the same step and consider all the factors with highest powers. Let's see LCM now. LCM is nothing but a smallest multiple or integer that belongs to the table of any numbers given to you. For example, let's say I'm looking for LCM of 12 and 48. Let's say my number, favorite number, 12 and 48. Table of 12 we write 12 into 12, 12 2s are 24, 12 3s are 36 and 48. Table of 48 you write 48, 96, don't have to go all the way, please check. The fourth number over here and the first number over here in the table of 48 is common. It means the least common multiple of the number 12 and 48 is what? The number 48 itself. Okay, so basically any number given as a question, for you to find LCM, write the table of them if you can and look for the first common multiple, the first common multiple in their tables. Okay, Now, other way around will be, you have to factorize it. After factorizing, look for factors, all factors with maximum or the highest powers. We'll see in the questions, don't worry. We'll see in the questions. I've taken so many questions. Total of, I think we're going to solve 25 plus problems today in the session. We will complete the entire chapter real numbers in one shot. We'll solve 25 plus questions. Okay, I think that'll be fair enough to get 6 marks. Alright, so this is clear. What is LCM? Either write the tables, look for the common multiples, or in the prime factors form, look for all the factors with the maximum powers. Now, LCM and HCF of two distinct prime numbers. Example, 3 and 17. 3 is a prime number or not? Yes. 17 is a prime number or not? Yes. Are they distinct? Of course. Distinct prime numbers. What is LCM? LCM is the product of the two. If A is 3 and B is 17, LCM is what? 3 into 17, how much is that? 51. If you have two distinct prime numbers, not numbers, prime numbers, you might say, sir, 4 and 6, sir. Sir, 4 and 6 are distinct. They're not prime. I'm looking for two distinct prime numbers, only prime numbers. In this case, what is the LCM actually? It is 12 in this case, because they are not distinct in nature. You have to apply the formula. Table of 4, 4 2s are 8, 4 3s are 12, 6 2s are 12, least count multiple is 12. In this case, they are different and they are prime. Only then LCM is what? The product. What about HCF? Always 1. Always 1. Because they are distinct. They are prime. First of all, they are prime means they have only two factors, the number itself and 1. Define the prime number. Prime number is a number which has two factors, the number itself and 1. 17 also, factors are 17 and 1. 3 also, the factors are 3 and 1. Then tell me how come it can have any other factor? Highest common factor will be 1 always for two distinct prime numbers. Okay. Moving on. Now comes the world of questions. Of course, we'll have concepts in between, but world of questions. Find the LCM HCF for 48, 72 and 80. We'll use the concept of prime factorization method over here. Apply for 48. Sir, we have here 4. 12. Sir, why are you doing 4 is not a prime factor? We can write 4 as simply 2 power 2, right? We can do that later, don't worry. 4 is this, 3 and 4. Okay. So 48 is what? 48 is 2 power 4 into 3. My bad, 2 power 4 into 3. 2 power 4 is 16, sir, and into 3 means 48. Done. Next up is 72. 72. What we have for this, sir? Same way. Sir, we can do 6, no? 12. We can do one more time 6, sir. 2. 6 is nothing but 2 into 3, sir. So we have 2 into 3, the whole square into 2. What is this? Please check. 2 into 2 power 2 into 3 power 2 into 2. We get 2 power 3 into 3 power 2. 9 into 8. Correct, 72. That's my prime factorization of the number 72. Next up, 80. 80 is what, sir? 80 is 8 into 10, sir. Basically, it is 16 into 5, sir. Basically, it is 2 power 4 into 5, sir, is the number 80, sir. Now, world of HCF starts. World of HCF. What did I say? Only common factors. Repeat in your mind. Only common factors with least power. Common factor. We have 2 common. Do we have 3 common? So 3 is common over here, but not in this. So only 2 common. Least power. So 2 power 4 is here, 2 power 4 is here, 2 power 3 is here. Least is what? Of course 3. Answer is what? 8. So 8 is the HCF. Common factor with least power. 8 is the HCF. LCM. So LCM is said all the factors with highest powers. So first is 2, highest power is 4. Next is what? 3. 3 highest power is, here we have 2. 3 square. Next is what? Next is, sir, 5. Multiply. 16 into 9 into 5. 16 into 5 is 80. 80 into 9 is 720. 720. Try to use multiplication in a way that is faster and accurate, okay? If you want, you can multiply 45 also, 9 into 5, but what is the point? If you multiply 9 into 5, it becomes 45. Then 45 into 16. Difficult to do that, right? 16 into 5 is 80. 80 into 9 is 720. Answer is this for LCM, this for HCF. Have a look. Have a look. Done, done, done. Question number 2 over. Let's move on to question number 3 now. If the HCF of 65 and 117, 65 is 13 into 5, 117 is 13 into 9, so 13 into 3 square is 117. Okay, this is HCF, right? Find HCF from here first. HCF is only the common factor with least power, 13. They're saying this is equal to this value right here. 13 equals to 65m minus 117. 13 5s are 13 9s are. I get 1 equals to 5m minus 9. 1 plus 9 equals to 5m. 10 equals to 5m. M equals to 2. Have a look. Check. Sir, that easy? Yes, that easy. 65m minus 117 is the HCF. Find the HCF, put them equal, solve for m. It's a linear equation. M value is 2. Question number 3, simple and done. Moving to question number 4 now. Let's go. Let's go, let's go, let's go. Come on, come on. If LCM of two numbers is 48, then which of the following number cannot be HCF? Now comes one statement you have to remember. Sorry, memorizing, sir, but remember please. HCF is always a factor of LCM. HCF is always, HCF of any two number is always a factor of LCM. Think, is 3 a factor of 48? Yes, sir. 16 a factor of 48? Yes, sir. 15? No. 24? Yes. It means only 15 is a factor of the HCF, and they are looking for which is not, cannot. Option C is correct. Option C, 15 is not a factor of LCM, hence in any of the world it can never be a factor, or it can never be the HCF. I'm not saying that 3, 16 and 24 is a HCF. Understand this. I'm not saying 3, 16 and 24 is the HCF. Because you might be thinking, sir, how can there be 3 different HCF? There is not. I'm not saying that. What I'm saying is 3, 16 and 24 are the factors of 48. It means they can be HCF. But 15, that is not a factor. It can never be HCF. Cannot be. Option C is correct. HCF is always a factor of LCM of any given numbers. That's the concept. Please remember it. This is not a question. This is a concept. I've taken a problem to explain you this. Okay, this is not a question, this is a concept. I wanted to explain you with the application. That's why I have done this way. Works now? Okay. Alright, next up. If two positive integers a and b are written in this way, x, y are prime numbers, then HCF of a and b is what? Okay. A, this. X cube, y square. B, this. X power 1, y cube. Okay, what are they saying? HCF. By HCF we know common factors with least power. Common factors are x and y both. Least power is 1 over here and 2. So my HCF is xy square. LCM. LCM we know all the factors. So xy highest power, so 3 and 3. Here 3, here 3. So if you remember this method, you will get the answers very quickly. You can actually visualize things happening in your mind. What is it? All factors with maximum powers, common factors with least powers. That's HCF and LCM. difference, sir. Question number 6 now. Question number 6 now. If 7 is the least prime factor of P, okay, what it means? If I am doing the prime factorization of this number, if I am doing the prime factorization of this number, I get 7 over here, and other numbers coming on these two places are more than 7. 7 is the least smallest prime number of P. Yes. Let's try writing for, they're saying for Q, 11 is the smallest prime number. I am saying there are more than one prime factors, but 11 is the smallest. Now think of an even number. Let's assume a W. W is a even number. Even number. This has no relevance to the question. Sir, why are you doing this? Because I want to explain you something. This has no relevance whatsoever to the question, and still will be helpful. Check. W, any even number. Which W? Not the Dhawan movie wala. That's a big W, right? Ye choto sa W. Small even number. Remember? Have you watched the movie Dhamal? One of my favorites. Maybe I'm an old person, that's why. Okay. Growing up, Dhamal was one of my favorite movie. If you liked it, let me know. Okay. We have a common taste. It's difficult to have actually. You guys are very young. But alright. W is an even number. A small even number. Even number means what? If you write the prime factorization of this, you will always have the least common factor as 2. For any even number, the least prime factor has to be 2. Correct? 2 is a prime number, and 2 was an even number. Even number means a number which divides by 2, divided by 2. Okay? So basically, for any even number, 2 is the least prime factor. It means that if 7 is the least prime factor of P, P is odd, Q is odd. Yes or no? In the world of maths and numbers, if 7 is the smallest prime number, it means P cannot be even. Because if P was even, then 2 would have been the smallest prime number. Same for the Q also. P and Q are both odd. P and Q are both odd, we have established with the help of our number W. Okay, W is not part of the question. P and Q are, but with understanding of even number and their least prime factor, I got to know that P and Q are both odd numbers. This is clear. P and Q are both odd number. This is bhaiya clear. Clear. Now, since P and Q are both odd, add them na. Add them. This is always even. Now, some of you might be thinking over there in the class, okay, backbenchers, are you thinking that way? I don't think so. You're very smart people, right? P and Q, add them. P plus Q. P plus Q. 2 odd. Think of a number. 13 plus 17. 30. 3 plus 5. 8. So 103 plus 17. 120. Any 2 odd number you take, add them. They're always even. Any 2 odd number you take, add them. They're always even. So P is odd. Q is odd. Sum is even. If it is even means for this number, let's say P plus Q is coming equal to a number X, which is an even number. It means for this number X, 2 is nothing but the least prime factor. Since P plus Q is coming out as even, of course 2 is the smallest prime number for that number, and hence we have the answer as 2. Got it? So this is a more logical question than actually solving it. I have not solved it. I have not given you any step. This question has 0 step. You make your own statement. Your English must be better than me. Make your own statements, okay? But logic. P smallest number, prime factor is 7, not even. Q smallest prime factor is 11, not even. Sum is even means of course it is going to be having 2 as the least prime factor. Sir, what if the sum was not even, sir? Then we cannot solve this question. Can you think of a number? Can you imagine by yourself that if the sum is not even, then there will be any odd number, right? For different odd numbers, there can be different smaller prime factors. We can't say 3, we can't say 5, we can't say 7. So if somebody is thinking in this way, sir, what if the sum is not even? What if that is there? Then we can't think. Then there will be no question like this. Okay? There will be no question like this. If you want, try it. Try and let me know. I will also learn something new. Okay? Come on. Question number 6 is done. Okay, question number 7 now. You must have had fun learning this question. An army contingent of so this question now over here looking very difficult, big word problem, very simple. Just think is this and this here. Please check this. If I am somebody, I will not look for this entire, if I am solving this question, I will not look for all the statements. I'll just look for 3 words. Now after reading these 3 words, I will not write the answer actually. I'll read back, but I get an idea. Okay, this is a HCF question. I get an idea. This is a HCF question. Numbers are there, maximum is HCF. But I'll read it anyway. I'll read after this to make a conclusion. But let's read it now. An army contingent of 104 members is to march behind an army band. Band is here. Band is here. Moving forward like this. The army contingent has to come like this. This is the army part. Okay. You're gonna part in the parade. Okay. Things happen. No, you must have done in the school as well. So army is behind. Band is in front. Moving forward. Excuse me. In the parade, in the army band, there are total of 96 men. 96 members actually, not men. This is having 104 members. The 2 groups are to march in the same number of columns. Same number of columns. We are looking for maximum number of columns in this. They can march. Very simple. Find the HCF. Okay, 104 HCF will be what? I can go with this. 2 times of 52. 2 times of 13 into 4. Correct? So I get 2 times 2 power 3 into 13 is my prime factor of 104. How about 96? For 96 we'll have 2 into 48. So we get 2 into 16 into 3. So 2 into 5 into 3. 2 power 5 into 3. That's this. We're looking for HCF. We're looking for HCF. How come HCF? We're looking for maximum number of columns. And they should be same. Means what is the maximum number of columns which is common between both of these? I'll repeat myself. What is the maximum number of column between both of these? And they should be common as well. So common maximum number of columns. HCF. Okay? Chaliye. Common factor with the least power. Common factor is only 2. Check here. So 2 with the least power, 3. Answer is 8. This is the answer. Answer is 8, which is the maximum number of column that they can have, they can march in, provided that they're both marching in the same number of columns. It'll become what? 8. It'll become 8. Basically, you'll have, check this out, you'll have 12 columns. Yeah, you'll have 12 members in each column of this thing. For the band, for the band you'll have 8 columns into 12 members. So this is the number of members. Number of members. Okay, so in each of the column of the band there will be 12 members, whereas in this case, what is going to be the case? 8 and 3, right? So 13 members. Yeah. So in the case of army contingent, you'll have 13 members per what? Yeah, per column. The column length will be different. Okay. In the one column of army contingent, you'll have 13 members. In one column of band will have 12 members. Okay, but number of columns will be same. Number of columns will be same. Is that clear? Please check. Beautiful question. Break it with the help of our understanding of HCF LCM. Important note, let XC be P by Q. Okay sir. P and Q are co-prime. Okay sir. This is assumption. That's why I'm saying okay. I can assume anything. I can assume your name is anything. I can assume anything in this world. Okay. People keep assuming, right? So why can't we do that in the same thing in mathematics? Let X equals to P by Q. P and Q are co-prime. No problem. Be a rational number whose decimal expansion terminates. Okay. Means this is a rational number and they're saying it terminates actually. It comes to an end. Then the prime factors of the Q, the denominator Q will always be having 2 and 5 as a prime factors. They will have 2 and 5 as a prime factors, and M and N are non-negative integers. Why non-negative? Then it will become, if let's say if Mn is negative, I get minus 5. what happens here? It will become 2 power minus 5. What is going to be this case? 1 upon 2 power 5. If you have a negative value, no, it will become reciprocal to it. That's why we can't have that. So basically, if I have to summarize all of this, it means that if you have a fraction, if you have a rational number, and it actually terminates, if you find decimal of that, the decimal is of what nature? Terminating nature. Then the denominator must be of the prime factors form of 2 into 5. It can be any power of 2, it can be any power of 5, but it must be of the form of 2 into 5. Clearly, please check. Done? Okay, now a question on this concept only. 21 power n. So it's not a fraction, it's not a rational number, is it not? 21 by 1. It's not going to give me any decimal form because there's no denominator other than 1, but it's a rational number, right? Yeah. Factorize 3 into 7 power n. Okay, I'll just have some water. Give me 1 sec. Alright, forgive me. So I had to have some water. Done with that. 3 into 7. Is it same as 2? For this to terminate with 0 or 5, think of a number. 10. 2 into 5. Think of a number 105. You'll have 2 into it, right? You'll have 5 into it. 5 into 2 into 1. Yeah. So we have, yeah, correct. So for a number to end with 0 or 5, it must have 2 or 5 in it. Yes or no? It must have 2 or 5 in it. In this case, 21 does not have 2 or 5. 2 or 5 is missing. It means it can of course never terminate with 0 or 5. As simple as that. Okay, great. Let's move on. Question number 9. Before that, a concept. This concept has been explained with the help of this question. The concept is, if you have HCF and LCM of any two given numbers, then there is a relation between the HCF, LCM and the numbers. What did I say? If you have HCF and LCM of any two given numbers, you can find that, right? I've taught you that. Then there exists a relation between HCF, LCM and the numbers. It's like this. HCF into LCM equals to the numbers product. The numbers product. Okay. Let's see on a question. How does it work? The ratio of two numbers is 3:4. What it means? It means therefore we can assume, no, let the numbers, the two numbers actually be, of course, 3x and 4x. If the ratio is 3 and 4, it means the numbers can be 3x and 4x. Divide them. X and x will get cancelled. Ratio remains as simply 3 by 4. Okay. Their HCF is 4. Alright. Find the HCF right now. HCF of 3x and 4x. How much is this? How much is the HCF of 3x and 4x? It's simply, sir, x. Right? Because if you write the number 3x, what's the product? 3 times of x, 4 times of x. So 4x. Okay. It means basically this is my HCF x. My x value is what? 4. They've given it here. HCF is 4. Okay. Super. Find their LCM. LCM will be given by, have a look. We can find this. We'll have the numbers 3x into 4x divided by the HCF. Please check. LCM into HCF is the number product. Okay. So in this case, what we have, 3x into 4x is the number product. This is the 3x as number. 4x also is the number divided by the HCF. Moving this HCF over here, basically. See here, 3x into 4x divided by, what is HCF? Again 4. This is also 4, right? So this x and this 4 will be cancelled. What I have the answer as 3 into 4 into x. How much is that? 3 into 4 into 4. How much is that? 48. Cross check, guys. This x is nothing but 4. I've used that over here. Okay. Question number 9 is also done. Question number 10 now. 9 was very simple. Right? The property is HCF times LCM is equals to product of the given two numbers. Find the smallest number which when increased by 20, smallest number, assume it to be x, life becomes simple. Increase by 20 is exactly divisible by these two numbers. Okay, think. Basically, they're saying that this is Okay, this is a multiple of 90, because they're saying that this number, smallest number added with 20 is divisible by 90. It means x plus 20 is a multiple of 90, also is a multiple of 144. So basically x plus 20 is the multiple of 90 and 144. 90 and 144. They've also given a word over here, smallest. They've also given a word over here, smallest. What does it mean? It means that we're talking with what? A multiple which is the smallest, LCM. It means that x plus 20 is LCM of 90 and 144. So find the LCM then. Find the LCM. 90, 9 into 10, 3 square, 2 into 5. 144, 12 into 12. What is 12? 3 into 2 square, the whole square. What I get? 3 square into 2 power 4. 2 power 4 is 144. I've got the prime factors done now. Look for LCM. For LCM, what we have? All the factors with highest powers. 2 with 4. 3 with 2. Because 3's highest power is 2 over here also 2. 5, simply 1. There's no 5 over here. Okay. So we're going to go with 16 into, multiply 5 over here. I get 5 into 9. 80 into 9. How much is this? 720. Now all of you will write this as an answer, and it's incorrect. If you write the answer as 720, your answer is wrong. It's not 720, it is actually x plus 20. Please check. What you got right now is the LCM. What is LCM over here? X plus 20 is the LCM. What are they asking? They're asking us x value. So 720 minus 20, x is 700. Got it? X is 700, not 720. X is 700. Because you increase this number to make it LCM. It was not LCM in the beginning. The number itself is not the LCM. After making it added with 2, then it became the LCM. Okay, so right now it is not the LCM. Is it clear? Please check. If you add 20 to it, it will become multiple of both of these. What type of multiple? Smallest multiple. What it means? LCM. How do you find LCM? Like this. LCM is 720, means answer will be 20 less of that. Answer is 700. Question number 10 is also over. Question number 11 now. A circular field has circumference of 360 kilometers. Circumference of 360 kilometers. Superb. Okay. 360 kilometers circumference. 3 cyclists start together, can cycle 48 kilometer, 60 kilometer, 72 kilometer in a day. In one day, they go 48, number 1, number 2 goes 60, and number 3 goes 72. Let's do one thing. Number of days to complete one rev. Let's find one rev. Because why we are doing one rev? Because dear, they'll meet after revolutions only, no? We'll see where they'll meet, of course. Then what are they asking actually? When will they meet? It means they're asking the time to us. They're asking us the time. In one day they go 48 kilometers. Let's find the time now. In one rev, number of days, how many they're taking? Okay. We'll have 360 by 48 for the first one. This is for the number 1. Cyclist number 1. Let's call it to be A actually. Cyclist ABC will call. Cyclist ABC will call. Okay. Cyclist A is going 360 by 48. That's 12 4s are, 12 3s are, that's nothing but 30 by 4. That's 15 by 2 days. 15 by 2 days. Why not 7.5? I'll tell you later. Okay. Next, B. For B, 360 kilometers, again same thing. Divide by 60 this time. Answer is 6 days. Answer is 6 days. Now C. See what is there? 360 again same thing. Divide by 72, I think. Yeah, 72 this time. 36 times 2 is this is 10. I get 10 by 2 is 5 days. So I'm getting here that 15 by 2 days is taken by A to get the 1 revolution. For B it is 6 days and for C it is 5 days. Super. Now think logically. Now your logic comes back. Now, so they're supposed to meet, right? They're supposed to meet. It means that there should be a component of will the number, you should think like this. Whether we are finding LCM or HCF, the resulting number, can they meet in less than 5 days? Can they meet in less than 6 days? Can they meet in 7.5 days? No. It means the resulting number when they meet again has to be bigger than all these three. And remember, HCF is the number always bigger than all these three. HCF is a number which is smaller than the given numbers. HCF of given numbers are either smaller or equal to them. But LCM is either equal or bigger. No, never equal, bigger than them. Okay. So basic idea is, yeah, it can be equal also at some cases, but usually it is either equal or more. HCF is either equal or less. We're looking for a bigger day. Of course, it's going to be what? LCM. For them to meet, it will take some time, right? LCM of 15 by 2, 6, 5. Now there's a fraction involved over here. So we write this everything as fractions. 15 by 2, 6 by 1, 5 by 1. Whenever you are looking for finding LCM of fraction, there's a formula. Find LCM of numerators 15, 6 and 5 and divide by HCF of denominators 2, 1 and 1. The formula is, if you're looking to find the LCM of the fraction format, do the LCM of numerator divide by HCF of denominator. LCM of 15, 6 and 5. Lowest common multiple of 15, 6, 5, 30. 15 2s are 30, 6 5s and 5 6s are 30. Divide by HCF of 2, 1, 1. Highest common factor of 2, 1, 1 is 1. Excuse me, is 1. HCF of 2, 1, 1. Highest common factor of 2, 1, 1 is what? 1. What's the answer? 30 days. So they'll meet back again in how many days? In 30 days. Okay. This is the first time they're gonna meet. Got it? Why first time? Because it is LCM, least common multiple. Two things to remember from here: the concept of using days, and the concept is of finding the LCM of a fraction format. Okay, done. 11th is done. Good question. Not difficult, but good question. Question number 12 now. If two positive integers a and b are written as a equals to bq, b equals to pq square, HCF is this, LCM is this. Find that. Okay, looking for HCF, right? HCF of P and Q. Please check. Common factors with least power 1 and 1. Compare with this HCF given to you. Compare these two. You get x value as 1, y value as 1. What is HCF? Common factors with least power. Common factor is what? P and Q. Power is 1 and 1. Here 1 and 2. We're going to take 1 and 1. Okay. X is 1, y is 1. What about LCM? All the factors with highest powers. PQ again, power will be 1 and 2. Compare with this. You get the m value as 1 and n value as 2. Compare these two. Okay. So what are we looking for? X plus y upon m plus n. What is the answer? 1 plus 1 upon 1 plus 2. That is 2 upon 3. That is 2 upon 3. Answer is 2 upon 3. Question number 12 also is over for you. Question number 13. Now before we do that, we are now into the world of irrational numbers. Irrational numbers. Question number 13 will be on the basis of irrational numbers only. But right now let's understand this very clearly. So basically the family tree of number system goes like this. Remember, start from counting numbers. If you're very kid, if you remember, I don't think you will remember, but if you remember the first time that you got to know the numbers was counting. Guest comes to your house, parents say, "Bacha, count karke dikhao." So the counting till 1 to 10, you'll start 1, 2, 3, 4 till 10. Next time, you can do the counting till 1 to 100, right? So that's how you got introduced into the world of numbers. If not you, at least me. Okay, for me, for older people like me, that's how, our parents used to give us a praise. Okay, fine. This guy knows our counting till 100, counting till 200, counting till 500. Of course, okay. So I never counted it. Don't ask me to count it like the 1 to 500. It'll take too much of time. But getting my point, first thing that came to our mind when we go to the numbers is basically counting numbers, and that is called as natural numbers. That is called as natural numbers. Then we said 0 is also there. If you add 0 to this, it will become whole numbers. Then we say we also have integers, we have negative value as well. Then we go to integers, z. That is the this is the notation for integers. Then we learnt about, okay, there is some decimals as well, so we call that rational number, q. Okay, rational number, q. Then we said actually there's something called as r, there's something called as real numbers, and in real comes another word of q dash. What is q dash? Irrational numbers. What is q dash? Irrational numbers. So basically we started from the counting numbers. The basic thing is we started over here counting numbers, we went to whole number, we went to integer, we went to rational number, and lastly we went to real numbers. Now I am saying that in the real numbers we also have a form called as q dash, which is given as irrational number. Okay, actually I am promising you, from a point of maths teacher, we have one more classification, but that is the last. We don't have after that. We have one more classification that you learn in grade 11. What is that? Complex numbers. I'll say you'll again have a Z, complex numbers. But that is the last. Pakka. That is the last. We'll not talk about that right now. We'll not talk about that right now. I'm not going to be troubling you right now with that. But as of now, understand, there's something called as real number. In that we have chapter's name is that real number. Okay. One part is rational, other part is irrational. Irrational notation is what? Q dash. That's your irrational notation. Now, understood? Okay, sir, this exists something called as, there exists a person with the name of irrational. Okay, you said that, I understand. Who are they? Who are these people? कौन है लोग, कहाँ से आते हैं, कौन है irrational people? Okay, so, कौन है irrational numbers? Who are these irrational numbers? Very simple. A logical person will say, whatever is not rational, sir, make it irrational. Whatever is not rational, sir, make it irrational. That is correct explanation. That is correct explanation. A rational person will say like that. A logical person will say like that. जो rational नहीं है, वो irrational है. सही बात है. But what are those numbers? What exactly are those irrational numbers? And there comes 4 points for this. A number which cannot be expressed. Remember, when we learned about the definition of rational, we said a number which can be expressed in the form of p by q is rational. P and q are integers and they are co-prime. We said that. In this case, the word comes, the can becomes cannot. In the definition of rational number, we had can be in the form of p by q. P and q are integers. P and q is co-prime. We said that. In this case, the word comes cannot be. Whatever numbers we cannot write in the form of p by q are irrational. First thing. Is it over? Of course not. Is it enough? Yes. But the word is of course not also comes. Point 2. Decimal, let's say you're dealing with. If you're dealing with decimal, example 2.41, 42, 46, 47, 48. Is there a pattern? Yes, sir, 4 is coming after every number. That's not a pattern. Pattern is called like this. 2.4444 like this is a pattern. 2.41, 41, 41, 41. These are called as pattern numbers. These two numbers are rational actually. Whenever you have a recurring form, repeating nature, it's called as rational. This is called as irrational. This is called as irrational. So whenever you have non-terminating, this number is ending or not? It's never ending. This number is never ending. So non-terminating and non-repeating means there is no pattern also. It's never ending as well. A given decimal to you which is never ending, keeps going on, and it is having no pattern is called as irrational. So far we have learned two things. P by Q के form में नहीं होगा. We don't have P by Q form, means irrational. We don't have non-terminating, non-repeating, irrational. Point number 3. Imperfect, basically cube root of imperfect cubes. What's the meaning of imperfect cube, sir? 4. Is 4 a perfect cube? No. 4 is a perfect square. What happens if you find cube root of 4? What happens? So far you have learnt to find square root of 4. Answer is 2. Life is easy, happy, done, good. What happens if I write cube root of 4? Is the answer going to be 2? No. The answer is not 2 anymore. This is called as irrational number. This is called as irrational number. For example, square root of 8. Is it 2? No. If I write cube root of 8, it's 2. Cube root of 8 is 2, but square root of 8 is not 2. So basically when you have imperfect squares, imperfect cubes, those are called as in this format is called as, again, what? Irrational numbers. The last one, P is a prime number. If P divides A square, then P divides A. This is actually, the last point is actually to understand the derivation of root 2, root 5, root 8. This has nothing to do with the definition of irrational number, okay? The first 3 points is, the first point was, if you cannot write a number in the form of P by Q, it's irrational. If it is non-terminating, non-repeating, no pattern question number is called as irrational. And the last is called as, if you have square roots of imperfect square, cube root of imperfect cube is basically called as what? Irrational numbers. Have a look. Okay, I hope you had fun. Okay, I hope now it is clear how the number family, the family of number system goes, from where we have reached so far, from where we are supposed to go. So all this is clear, right? Okay, I can proceed with the questions now. Let's start the questions. Next, proving root 2 is irrational. Okay, now this is one of the most common question, and I know all of you know it. If you don't, it's okay, I'll explain you everything step by step in this detail. After learning this concept right now, no, I'm telling you, will not make any mistakes. There's only one thing which is very important, these steps. This here I've written already, right? This, if a prime number, if P is a prime number, and if you have that P divides A square, if a prime number divides A square, it will also divide its number A. We'll see that, don't worry. Okay, and fortunately for us, actually this question keeps coming up once in a while, means every once in a 2 years or 3 years this question comes up. Okay, maybe this year can also, this question has to be asked or can be asked. Okay, let's check. Let's solve this question right now. Proving root 2 is irrational. Okay, of course it will have the derivation, so it will require some space. Understand, first statement is prove make an assumption. Okay, make an assumption. Assumption is what? That actually root 2 is rational. So we'll start from this place, and later we'll say that our statement is wrong because of a contradiction. Starting with the complete opposite case, I'm taking it as root 2 is rational. Now how do we define rational? It should be of the form, P by Q, and P and Q are co-prime integers, right? Co-prime integers. What it means? Co-prime integers means they are both integers and they have only one number common, which is common factor, which is 1. So we have P and Q has only a common factor as 1. Basically, I've written here to explain you what it means to be co-prime. Co-prime means that there's only one common factor, that is 1. This much is our assumption. Next up will be, let's start solving it. They have given us what? We can take this as root 2 equals to P by Q, because we have taken this as rational form. From here you continue, bring this Q on this side, we get P equals to root 2Q. I've taken Q multiplied with root 2, so I get P equals to root 2Q. Next will be squaring both sides. What we end up with? We get P square equals to 2Q square. Now what does it mean? I'll show you. Let's say if I have 64, can you say 64 is 2 times of 32? Can you say 64 is 2 times of 32? Yes, you can say that. What it means? It means 2 is a factor of 64. All of you agree with me? 2 is a factor of 64. Okay, now, so from here what we understand? We understand that 2, compare this with that case. 2 is a factor of 64. Okay, now take root of 64. If this is 64, we can write this as 8 square. So we can say what 2 is a factor of? Simply 8 square. What it means is 2 is a factor of 8 as well. 2 is a factor of 8 as well. How can I say that? 8 equals to 2 times of 4. 2 is a factor of 8 as well. So same way, here 2 is there, right? 2 is factor of P square from this statement, and it means that if 2 is a factor of P square and 2 is a prime number, 2 is also a factor of P. This is not 64, forgive me. This is P square actually, okay? I made a mistake. This is a P square. So if 2 is a factor of P square, then 2 is also a factor of P. Basically, I have established one thing, that 2 is a factor of p. This is my conclusion over here. If 2 is a factor of p, I can write the p as twice of k. I'll keep this as my equation number 1. I'll keep that as my equation number 1. I'm writing p as twice of k. Why, sir? Because p is like 2 is a factor of p. 2 is a factor of p. It means p is equal to some number k. Some integer we can take, some constant we can take as 2 times of that number will be equal to p. Superb. Okay. Now square both sides for this. Squaring both sides for this statement. So far what we have done only one thing, assumption and establishment of 2 is a factor of p. Okay, let's continue. I'm going to erase this. This is the same principle. Okay, if we have p as a prime number, remember 2 is a prime number over here. If it's a factor of a square, also be a factor of, or basically in this case p square will also be a factor of p. Will also be a factor of p. Next up, carefully, p we are looking for squaring both sides. We get here as p square equals to 4k square. Okay, and we have value of this from here. Substitute back in this. What we get? We get this as 2q square equals to 4k square. Cancel this 2 with this 4. I get q square equals to 2k square. Okay, now compare from here. Same condition, right? From here, p square equals to 2q square. I wrote 2 is a factor of p square. Same, what I'm going to do over here? 2 is a factor of q square. What is it? 2 is a prime number. It means 2 is a factor of q as well. 2 is a factor of q as well. Now this is my conclusion. We'll make assumption from here. Please check. So we have these two statements coming back in now. Statement from here, 2 is a factor of p, 2 is a factor of q. What it means? It means 2 is a common factor of p and q. It means 2 is a common factor of p and q. And this statement over here, this statement is very, very important. Okay, this statement over here is our most important line, also called as contradiction. Contradiction. How can I say that? We assume that there is only one common factor, which is 1. We started from where? Only one common factor, which is 1, and we are reaching what? 2 is a common factor. It means either this is wrong or this is wrong. Okay, that's why we can say this is a contradiction. And because of this contradiction, and how does this contradiction comes to us? Because of our assumption. Starting from here, right, we are making this assumption, and based upon this assumption I'm getting a contradiction. It means this must be wrong. Therefore, what is the last statement? Hence our assumption is wrong. Hence our assumption is incorrect. So what was our assumption? It is rational. Incorrect means it is actually irrational. We have proved it. Please check. You must write over here, hence our assumption is incorrect. Hence, therefore, the value root 2 is actually irrational. Have a look. So we have 3-4 key points over here. First is assumption. Understanding that it is co-prime means only one factor, which is 1. Only one common factor, which is 1. Next is writing the expression as p square equals to 2q square. It means over here 2 is a factor of p. Next step is again same way, 2 is a factor of q. Combine these two, you get 2 is a common factor, which means contradiction. Hence we have as our assumption as incorrect. Answer is proven. The question is proven. Please check. Answer is complete. 13th is clear. Now question number 14. Okay, so we have similar questions of irrational forms, not always. So what happens? So as I said, once in a while it keeps coming up. This previous question, it keeps coming, let's say every 2 years, 3 years, this question will come. Either root 2, either root 5, root 4, sorry, not root 4, root 3. Root 4 is 2, right? So not irrational. So of course this question keeps coming up every once in a 3 year, 2 year, like that. Then what other year they ask? They ask this kind of question. Root 2 plus root 3 is irrational. Okay, let's see. Same thing is there. Assume it to be rational. We have to take our assumption. Our assumption is that root 2 plus root 3 is rational. And what it means? It means it is equal to P by Q. Okay, so right here P by Q equals to root 2 plus root 3. Bring the root 2 on that side, I get P by Q minus root 2 equals to root 3. Now in this step you do squaring both sides. Squaring both sides, because this will become 3, right? That's why. This will be what? P square Q square. A minus B the whole square will be what? A square plus square of this B square. A square plus B square. Square of root 2 is 2 minus 2 times of P by Q times of root 2 equals to square of this will be simply 3. Will be simply 3. Okay. Do one thing. Bring this number 3 on this side. I get P square upon Q square plus 2 minus 3. Okay, and moving this term on this side, we get 2 root 2 P by Q. 2 root 2 P by Q. This is simply simplification. Okay, nothing new is there. I move 3 on this side and move this term on this side. Okay, what is this? P square by Q square minus 1 equals to 2 root 2 P by Q. Continue. 1 second. Check. I can take LCM over here. I'll have P square minus Q square by Q square equals to 2 root 2 P by Q. Except for the root 2 term, bring on this side, all the term on this side. What I get? P square minus Q square times Q divided by 2P equals to root 2. And of course we had Q square earlier, this Q square. This cancels. What we have? P square minus Q square divided by 2P Q equals to root 2. Think about it. P and Q are what? P and Q are integers. They are rationals. This will be rational only. Difference of a square of rational numbers will be rational. Product of rational will be rational. Okay. It means this LHS side. This LHS is what? LHS is actually rational. What about RHS? This is RHS. RHS is what? Root 2, which is what? Irrational. Irrational. Now tell me, can LHS be rational and RHS be irrational? The two sides of the equal to sign cannot be of two different form of numbers. Okay, it means this cannot be true. This is a contradiction. So this whole thing you see over here is a contradiction. Okay, contradiction. And how did we get this? We got this because of our assumption. This is the contradiction and we got it because of our assumption. It means our assumption is incorrect. Okay, please write it down. Assumption is incorrect. Assumption is incorrect. That's your answer. Okay, got it? Your LHS side is rational, your RHS side is irrational. It means not possible. Okay, have a look one more time before I move on to next question number 15. All right. Question number 15 now, MCQ, exam style question. It's a PYQ as well. Okay. Two positive integers P and Q can be expressed as, okay, they've given P over here, right? P, 18a square B power 4. And what is Q? Q is 20 a cube B power 2. A cube B power 2. Okay. A cube B power 2. What are they asking? LCM of P and Q. LCM is what? LCM is all the factors with their maximum powers. So forget about the numbers right now. We'll see the numbers later. Let's look at the variables. A and B, we have highest power of A is what? 3, right? A 3 and highest power of B is 4. A cube B 4. We have only one option, D. If we had more than one option with the term A cube B 4, then what we're gonna do? Then we'll look for the we have to make the LCM of 18 and 20 as well. Okay, which is clearly 180, right? LCM of 18 and 20 is what? Clearly 180. But in this case we don't have to do that because it is simply for the variable it is coming as A cube B 4. Okay, of course there's a number over here, we don't need that. We have only one option as A cube B 4. Option D is correct. Clear? Now we have question number 16. The HCF of two numbers 65 and 104 is 13. Okay, HCF is 13. This is my HCF. They're asking LCM of this is my LCM. What are they asking? Value of x. We all know that 13 into this value 40x will be equal to product of the number 65 into 104. Correct? LCM into HCF equals to product of numbers. We all know that, right? This much we know. Okay, please check. 13 5s are, okay, I'm getting here x equals to 5 into 104 by 40. 5 8s are, 8 1s are, 8 3s are. It means x value is coming as 13. X value is coming as 13. Option B is correct. Now this is actually use of what? This is actually use of calculations. But if you want to use logic, you can solve this question within 1 second. Think about it. HCF is 13. Both numbers are product of 13, right? Both numbers are multiples of 13, right? Then even LCM will have 13 as a factor, right? Think logically. Even LCM will, in HCF you have 13. In numbers you have 13 everywhere. Means 13 is a factor of all the numbers and even the HCF. Okay? Then of course in the LCM value which is coming as 40 into x will also be having 13 as one of the factors. Yes, okay. Can you find 40's factor as 13? Can you find the factor of 40, the number 40 as 13? Basically, is 13 a factor of 40? It's not. It means this x has to be multiples of 13, right? This has to be multiples of 13, right? Correct? This x has to be multiples of 13 and we have only one such option. Option B is correct. So no need of doing this all thing. This is method number 1 and method number 2 is logic. Method number 2 is logic. It's actually conceptual only, but this is your brain working without your pen. Okay? Your brain working without your pen. Over here you are doing calculation. Both of them are correct. You can prefer any of the method, but I'm just giving you both. Basically, I'm trying to develop your skill to think in the problem. Okay, that's my goal. It's not. The thing is because, bacha, what happens, no? This question might not come in the examination. Then in the exam, I will not be there with you to help you out there. I will not be there for you to think for you. Okay, so of course you have to build your ability to solve a problem, to think of a question in a different way. Okay, and that's the method number 2 over here, using your logic to get the answer in 1 second. Not a factor of 13. We got to introduce 13 over here. It means B is the only option. 1 second is over. Question number 17. Now this is a very good question. Superb question. N square minus 1 is divisible by 8 if n is what? Forget about option 1 and 2 because it's very vague. An integer, a natural number. Okay, very vague. We'll see. We'll come to that later. Right now, we have odd and even. Sir, still we have so many odd numbers, so many even numbers. But can you know and write the form of odd number? Even numbers form. If I write it as 2 times of k, k whether it is odd or even, k whether it is odd or even, twice of k is always even, right? 2 times of 7, 14, even. 2 times of 4, 8, even. Okay? So whatever number you take as k, 2k is always even. You all agree with me? Pakka? Okay. Put it here. What is the number given to us? N square minus 1 should be divisible by 8. We'll see that later. Put n value as 2k. 2k the whole square minus 1. 4k square minus 1. No conclusion. Can you say from here? If it is divisible by 8, no? It means if I divide 4k square minus 1 by 8, I should get 8 cancelled, right? Can you do that right now? Of course not. Means no conclusion. Will depend upon what is the value of k1 in all the cases. We can't say that for sure. Okay. So we don't have a conclusion like this. It means this is not possible. It means even not possible. Let's look for odd now. How do you write when n is odd? You had even, right? Add 1 to this. 2k plus 1. 2k was even. Plus 1. A number next to even number. A number next to even number is odd number, right? Next to 2, 3, odd. Next to 4 is 5 or 3, both are odd. So you can write 2k plus 1. You do that? Okay. This is the form of odd number. Put this back in the expression. What do you have? N square minus 1. This becomes 2k plus 1 the whole square minus 1. This becomes what? 4k square plus 1 square is simply 1 minus, plus 2 times of 2k. 2 times of 2k into 1, and we have minus 1 this value. Okay. So this 1 and this minus 1 cancels. What I have so far is 4k square plus 4k. Correct? If you're not sure, do your own calculation. Okay guys. What I'm looking for, n square minus 1 by 8. So we have 4k square plus 4k by 8. If I can divide the 8 completely, means question is solved. Okay, take 4k common first. You get k left over here, and you get k plus 1 left over here. So k plus 1 divided by 8. 4 into 2 is 8, cancelled. What I have left now? K times of k plus 1 by 2. Now here the logic comes back. Okay. If k is odd, what is k plus 1? Even. If k is even, what is k plus 1? Odd. Basically, k and k plus 1 are consecutive numbers, whether it is integer, natural number, whatever it is. Okay, but it is a consecutive number. Okay, so basically what I have over here, I'll take, this is nothing but product of odd number into even number by 2. One of them is odd, the other one is even. If you divide them, of course you can cancel these two, right? You'll have something coming over here. It means you can say that you are getting the division possible. It means you are able to divide n square minus 1 by 8. Your 8 is completely gone from the denominator. Okay, so basically if you took the n value as odd number, you got rid of the 8 in the denominator. This is nothing but 1 now. It means we are able to divide 8. Okay, hence the answer is option C. Option C. Get it? It's a super problem. Okay, again, you don't have to do all the steps. Nothing. You can do all of this in your mind, right? You can do this calculation in the mind. You can do this also in the mind. You can't do that? I think you can do that. If you're even 50% good in algebra, you can do this calculation in your mind. Okay? You can do this calculation in your mind. Maybe this last step you can solve on the paper. So question number 17 is over. Moving on to question number 18 now. Once again, 18 now. LCM of 120 and 48. 120 and 48 LCM. Very simple. 120 factors you look for. We have 6 into 20. 2 power 3, okay, sorry, 2 into 3, right? What I'm saying, 2 into 3, and we have 4 into 5. My final answer is nothing but 2 into 4 is 8. It means 2 power 3 into 3 into 5 for 120. Okay, what about for 48? 48 is nothing but 16 into 3, so we have 2 power 4 into 3. What are we looking for? LCM. What is LCM? All factors with maximum power. So 2, 3 and 5. Maximum power is 2 is 4, 3 is 1, 5 is also 1. 16 into 3 into 5. 16 5 is what? 80 into 3, 240. Answer is option D. Please check, guys. The answer is option D. Again, you might have a different method to solve this question. You might have a different method, faster method to solve this question. Please go ahead and use that. Answer is option D. Question number 19 is your assertion reason. HCF of two numbers is 8 and their product is 1536. The LCM is 162. Let's check. We have the property HCF into LCM is equal to the numbers product of numbers. Okay, that's the formula. But we have HCF and LCM 8 into 162. Okay, and this should be equal to what? 1536. 8 to the 16, 8 6 is 48 plus, okay, 8 to the 16 we have 48 plus 1 is 49, 8 1 is 8 plus 4, 12, right? 1296, not equal to 1536. Am I right? Please check the multiplication once. 8 to the 16 carry is 1, 8 6 is 48, carry 1 means 49, 9 is there, 8 1 is 8 plus 4 is 12, not equal. It means statement 1 is wrong. It's wrong, sir. If it was the product of numbers is 1536, this cannot be 162, it will be something different number, okay? It will be something different number. Please check. You want to do that, you can find like this, 1536 by 8. 8 ones are, we get here 9, we get 7, right? 7 3 means 8 9s are 72, 1, answer should be 192, not 162. Your LCM will be 192, not 162, okay? Please check. If A and B are two positive integers, LCM is correct. This is the property we use right now. So we have assertion is false, reason is true. Assertion is false, option D. Have a look. Assertion is false, reason is true. Question number 20 now. Question number 20 now. 3 is a rational number, correct. 3 is a rational number, we can write 3 as 3 by 1. It's a rational number. 3 and 1 are both integers and their HCF is 1. The square root of all positive integers are irrationals. Square root, okay, of all positive integers are irrationals. Not necessary. Root of 4 is 2. Is 4 a positive integer? Yes. Is it giving me a rational result? No. Reason is false. Option C is correct. Please check. Assertion true, reason false, option C is correct. 21 now. Another assertion reason. Yeah. Root 2 is a rational number, correct. The square root of prime number is rational number, okay. Prime number, root 7, root 3, root 2. They're all irrational, right? They're saying it is rational. It means it's false. So again, A is true, R is false, option C is correct. Correct? Right? Assertion is true, reason is false. Okay. 22 now. Question number 22. So that the number over here, I have given this, done this question, please solve it. It's a P by Q, it's a homework. I've solved this as my question number 1. This is your homework, okay? Next question. Two numbers are in ratio 2 to 3, okay? Ratio is this, it means let the numbers be 2x and 3x. They're given the LCM, right? LCM is what? 180. What is the HCF they've given? They're asking us what is the HCF value actually. Okay, we all know the property. LCM into HCF equals to product of numbers. Okay, product of numbers. We're looking for HCF right here. HCF equals to product, this whole thing divided by LCM. Continue like this. So we get HCF, right, is equals to what? Product is how much? Product is going to be 2 into x times of 3 into x divided by what? Divided by LCM, which is what? 180. Okay, we get this 2 3's cancel with 6, right? 30. I have x square by 30 as my HCF. What's my HCF? X square by 30. Please check. X into x, 2 into 3 is 6, 6 3 is 18, which is 30. Okay, so this is the HCF. Now we're going to use LCM and the numbers to find the x value. Okay, LCM for 2x, what is the factorization? 2 into x of course, and for 3x, what is the factorization? 3 into x of course. What's the LCM then? LCM is 2 into 3 into x. 2 into 3 into x. That's my LCM. Right here, 180 equals to 2 into 3 into x. I get what? 30, right? I get 30, no? X is what? X is my 6, yeah, 30. I get x as 30. X value is coming as 30. Put it back over here, you get answer as HCF will become what? Equal to 30 square by 30 from here. X is coming as 30, right? What is the answer for HCF? 30. So your HCF is coming as 30. If you want, you can cross check. You can cross check over here. Your LCM is 180, your HCF is 30. And what is the product of the numbers? You have 2 into 3 into 30, right? Correct? Sorry, 30 square. 30 square, no? Yeah. Product is 2 into 3 into, here product. What is the product here? 2 into 3 into x square. So I get 6 into 900, right? That is 5540. Yeah, same thing. Please check. Verified. Alright, so x value is 30 and so is the HCF value. So is the HCF value. Again, you might have a faster way to solve this question. Please do. You might have a faster way to solve this question. Please use it. Done. Over here, clear. Next up. Given root 2 is an irrational number, prove that 5 plus 3 root 2 is also irrational. Okay. So first of all, I said this to you in this kind of question. First step is assumption. What I get? 5 plus 3 root 2 is rational. That's my assumption. What it means is 5 plus 3 root 2 equals to P by Q. One second, guys. 3 root 2 equals to P by Q. Alright. If it is rational, means it has to be in the form of P by Q, right? Now, keeping root 2 over here, rest all numbers should be moved on this side. P by Q minus 5. Okay. What I get over here? P minus 5Q by Q. Okay. Then you move this 3 also over here. What I get? I get root 2 equals to P minus 5Q by 3Q. Please check. P is integer, Q is integer. So this will be integer only numerator. Again, same 3 into Q will be integer. It means my RHS is what? Rational. What about LHS? Is root 2, which is what? They have given it as irrational. If LHS is irrational, RHS is rational, not possible. This is the contradiction. This is my contradiction, sir. Okay? What it means is our assumption is incorrect. Therefore, this 5 plus 3 root 2 is not rational. What it means is irrational. Hence proved. Done. Please check. A very simple question. A very, very, very simple question. Okay? Alright. Let's move on to another case study now. We'll solve the case study. So I have solved P by Qs. I've solved a lot of questions. So if you still have some doubt, if you still want something else from me, let me know that in the comment section. Now we are moving to the case study. Let's solve this question. Khushi wants to organize a birthday party. Being health conscious, she decided to serve only fruits in a birthday party. Superb. She bought, okay, a lot of people might not go. You might have some chocolates and cakes, right? Okay, but in this case, she has decided to be only considered with health, and she's gonna distribute only fruits. Superb. She bought 36 apples and 60 bananas and decided to distribute fruits equally among all. Equally, this word is very important. Otherwise, what will happen? No, the concept of HCF LCM will be lost over here. Okay, equally among all. 36 and 60 bananas are 36 apples and 60 bananas are there. Okay. Now, based on our information, answer the following question: how many guests Khushi can invite at the most? Think about it. One thing is, of course, going into the whole process, what we have to find out. Okay, one thing is the logic. The logic is the number of guests. Can it be more than the apples and bananas? No. LCM is what? Always equal to or more than the given values. Of course, they're asking to find what? HCF. Now get back into the maths part. Logic gives me that it is actually HCF. Now mathematics, I'm looking for a common value. Mathematics I'm coming back to. Logic gave me HCF because I'm looking for a number smaller than these two. then only I can distribute, right? If I had number of people more than the number of apples, how will you give the number of apples? Cutting in pieces and giving it to them? No. Okay, you have to give them whole apples, right? So of course it is HCF. But now coming back to mathematics, C is looking for number of people, okay, a common number of people which can get equal amount of the highest number of people which can get equal amount of both the apples and bananas, and this should be exhausted, means banana and apple should be over. So HCF of what? 36 and 60 is the first step. Solve here. First step is what? HCF means 36 and 60, right? You can see over here we have 36 as, okay, 6 into 6, right? So we have 2 into 3 power 2, what I get? 2 square and 3 square, okay? Yeah. And for 60 what we have? 12 5s are, okay? So I get 2 square into 3 into 5. Look for HCF. What is HCF? Common numbers, okay? So we have common factor as 2 square and 3. Please check. 4 into 3 is 12. Okay, so HCF is 12, sir. HCF is 12. That's the maximum number of people that C can invite, maximum number of guests C can invite. This is the maximum number of guests. Maximum guests can be invited as 12. Option number 1 is over. Next up, question number 2. How many apples and bananas will each guest get? Okay. Excuse me. So we have question number 2 now. This is 1 actually, and this is 2. 1 second, guys. Yeah, this is 2. The numbering is different, okay? This is 2. So we have total of 36 apples. 12 guests means each guest for apples will be what? 36 by 12. We'll get 3 apples, and for bananas what we get? 60 by 12, so 5 bananas. So answer is 3 apples and 5 bananas. Each guest, when the guest list is of 12 people, will get what? Will get 3 apples and 5 bananas. Superb. Moving on. Now this 3A part, first 2 carries 1 mark, this carries 2. Either 2 or this is option, okay? Either you solve 3A or B. I'm going to solve both, of course. 3A or B. If Khushi decides to add 42 mangoes, how many guests Khushi can invite? So there's a third combination coming. You had apple, you had banana, now mango is coming back. A is 36, 60 and mangoes are 42. Now she's looking for another guest list. Condition is that they all get equal amount of fruits, okay? So we are going to again look for HCF of all the 3, 36, 60 and 42. Of course you can use this method to get the answer. Think about it logically. 6 into 6 is 36, 6 into 10 is 60 and 6 into 7 is 42. You cannot break down 42 in any different way, any larger way basically. You can't have a larger factor than these two. 6 into 7 is 42. You can have 42 into 1 or 21 into 2, but that will not be common factor of 36 and 60. The larger factor than 6 and 7 is 21 and 42, which is not a factor of 36 and 60. It means 6 is the only common factor between 36 and 60, which is the highest in nature. So my HCF is what? Is 6. This is the guest. 6 guests can be coming. If you add 42 mangoes, you can ask maximum of 6 people to come and get equal amount of what? Mangoes and apples and bananas. So basically each will get 7 mangoes. We have 6 means 10 bananas and we'll be getting 6 apples. Last, this is 3A, okay? This is 3A. Now we are going to 3B. What is asking in 3B? So the question is, if the cost of 1 dozen of bananas is 60, 1 dozen is 60, okay? And the cost of 1 apple is 15. So 60, 15 and 20, okay? 1 dozen is 60. See what? 60 bananas, right? It means 5 dozens. 60 into 5, right? Excuse me. 6 into 50, okay? 60 into 5 actually. So 300 rupees for bananas. This is my 300 rupees for bananas. This is all for bananas. Let's move on to apples. C got each, so they got 36 apples and each cost is what? Each cost is 15 rupees. 15. Okay, so we get 15 6 is 90, carry is 9. 15 3 is 45 plus 9 is 540. If you're not sure, please do your own calculation, guys. If you're not sure, please do your own calculation. Not with the help of calculator, in your mind, on the paper, okay? This is 540 for apples. Now we're moving back to the mangoes. Mangoes, we got 42, each costing 20 rupees. Please check. 20 rupees for one mango. Cost of one mango is 20 rupees. It means what we have over here is 840, right? So I'm looking for total cost, right? What I'm looking for is total cost. Find the total amount spent on the entire set of fruits. I'm looking for total cost. So have a look. It'll become what? Total cost, right? Total cost would be sum of all these three. So 300 plus 540 plus 840. Add them. I get 0. I get 8. 8 plus 8 is 16. My answer is rupees. If it is rupees, then rupees 1680. Rupees 1680. Have a look. Rupees 1680. Okay. So case study is done. All the 4 parts, 3 and 3B, they're optional, but okay. Got it? Moving on. That's it for the session today. So we have completed our chapter, real numbers. I hope you had fun. I hope I've covered everything which is there in this chapter. If I have missed something, you got to let me know in the comment section. But that is it for today. I'm going to see you again very soon with another informative session or on a lecture. Till then, you have to wait and take care of yourself. Bye-bye.